All right, we finally made it to our last video, and we're switching gears and we're switching to the stats side, and we're going to look at probability. Okay, probability can be kind of tough because it's more of a thinking kind of topic, right? It's not just going back to basic math. You got to kind of think about what it's asking for. So in general, if you're trying to find the probability of something, it's going to be a fraction. So you're going to take the probability of what you want, so what you're looking for, divided by the total number of outcomes. So what you want divided by the total. Okay, so for example, if I want to roll a 2 on a 6-sided die, so I have 1, 2, 3, 4, 5, and 6. Those are my options anytime you roll a die. So that means that my bottom is going to be 6 because I have 6 total options. If I want to roll a 2, there's only 1 2 on there. So that means that what I want has 1 chance out of 6. So my probability is 1/6. Your probability can be a percent, a fraction, or a decimal. Okay, it doesn't matter. I usually write everything in fractions, but it depends on the way the problem's worded. So we're going to there's so much probability we can look at, but we're going to kind of focus it down to the basics, all right? And we're going to have 2 scenarios. It's either going to be basic, or 3 technically. It's going to be basic, like rolling a 2, or we're going to have 2 different events, 2 things happening. So it's going to be an and or an or. So for example, it might be rolling a 2 and rolling a 4, okay? Or it might be rolling a 2 or rolling a 4. Right, so a symbol for it, if I'm and, I use the upside down U, okay? So that means if I want probability A and B to happen, that's how we label it. Or is the U, so I say A or B. Okay, so the and is an upside down U, the or is a regular U. Right, if it's an and, we're going to multiply. That's our main operation. If it's or, we're going to add. So if it wants you to find the probability of drawing a king and drawing a jack, you're going to end up multiplying somewhere. If it wants you to find the probability of a king or a jack, then you're going to end up adding somewhere. Now, to multiply, we have 2 different scenarios. Okay, so for example, if I wanted you to draw a card from a deck, you have 2 scenarios in terms of drawing 2 cards. Let's say I want you to draw a king and a jack. For me to draw the first king, it's going to make a difference whether or not I put that card back in the deck before I draw again. So we say we have with replacement and without replacement. So if I draw a card and I put the card back in there and draw again, I'm starting fresh every time. That's what we call independent. The second time I draw doesn't matter what I drew the first time. Okay, so this is without replacement. Right? So that just means I'm going to take the probability of A times the probability of B. I'm just going to multiply my probabilities and get my answer. Right? Another independent event is flipping a coin. Right? I can take a coin and flip it, and I have a 50-50 shot of getting heads. Right? Then I'm going to pick up the coin and flip it again, and I have a 50-50 shot of getting heads again. Doesn't matter if I got heads on the first time because I start from scratch every single time. So I could flip a coin 5,000 times and get heads every single time. It's possible. All right? If I go to flip it again, I still have a 50-50 chance of getting heads. It does not change each time. All right? Dependent is when the first event affects the second event. All right, so this one's going to be, I don't know what I'm doing. Independent is with replacement. Sorry, so I take the card out and I put it back in there. Goodness. Dependent is without replacement. So I take the card out and I leave it out. So if I draw, we have 52 cards in a deck. So if I draw out a card, so let's say I draw out that king, right? I have 1 less card to choose from. That changes the probability for the next card that I draw. So what we do is we say we take the first probability times the second one given that A happened. That's what that line there means, all right? So that means that we're going to change the total outcomes for the second probability, for B. All right. The ORs, the adding, we have two scenarios for that as well. All right. So the ORs, well, let's do something else first. And means I have two separate events happening. Two events, right? I'm going to draw two cards, or I'm going to roll a die twice, or I'm going to flip a coin 4 times. So I have at least two events, or 2 plus events. Two separate events happening. For the OR, it's one event, but I'm looking for multiple outcomes. Okay, so this is one event, okay, but I'm looking for multiple outcomes. So we have two scenarios. The first one is if my outcomes have nothing in common. So for example, if I want to draw a king or a jack the first time I draw out of a deck of cards, there's no way for me to get a king and a jack. So if they're mutually exclusive, they have nothing in common. You cannot get both. That's when I'm going to take the first one plus the second one. Just take my two probabilities and add them together if they have nothing in common. But if they do have something in common, that's when they are non-mutually exclusive. So that means that we're going to have to subtract the both probability, all right? So that means that you can get both at the same time. Okay, so that one we're going to do the probabilities, add them together, and then subtract the both. And we'll kind of talk about that in a second when we look at an example. All right, this is all a bunch of gibberish, I'm sure. Hopefully it'll start to make sense when we look at some actual examples for finding probability. So, for all of these, I promise it doesn't take that long. For all of these problems, I'm going to use this one bag of marbles. So I have 4 red marbles, 3 green, 17 blue, 5 yellow, 2 orange. Right? So right off the bat, let's count how many we have. So you have 4 plus 3 is 7, plus 7 is 14, plus 5 is 19, plus 2 is 21. So I've got 21 marbles in this bag. So to start with, I want to find the probability of drawing a red marble. Okay, well, to find a probability, basic probability, I take what I want over the total. So I want red. I have 4 red. My total is 21. I can't simplify it, so my answer is 4 out of 21. That's it. There's your probability. All right, the rest of these are looking for multiple things. So the first one, I have 2 red marbles without replacement. So that means I want to draw 2 red marbles. So that's 2 events. So this is an and. Even though it doesn't say it in the problem, I want a red marble and then another red marble. I'm drawing twice. All right, so now without replacement means I'm not putting it back in there. These are dependent events. Okay, so I'm going to start with drawing the first red marble, which we just did. So drawing that first red marble is 4 out of 21. Okay, and I'm going to multiply because it's and. Okay, but to find the second marble, okay, we're going to assume that I drew that first red marble out. So that one red marble is out of the bag. That means when I go to draw another red marble, I have 1 less marble, specifically 1 less red marble. So that means that what I want, I have 3 red marbles in there out of 20 marbles that are left because I took out a red marble. So dependent means that my second probability changes based on what my first event was. Then to multiply straight across. So 4 times 3 is 12. Okay, then we got 21 times 20, which is 420. Right, I'm going to use the calculator to help us simplify quickly. And we get 1 over 35. So there's my probability for both events happening. All right, the next one is an or. All right, so if I have a red marble or a yellow marble, this means I'm drawing one time and I want to get either a red or a yellow. I cannot get red and yellow at the exact same time, which means that these are going to be mutually exclusive events. All we have to do is add our probabilities. So to get a red marble, we said was 4 out of 21. To get a yellow marble, it's going to be 5 out of 21. Okay, we already got our common denominator, so we get 9 out of 21. Divide them both by 3, and we get 3 over 7. There's my probability. Okay, so if it's or, we add. Okay, number 4, we got a red and a yellow marble with a replacement. So anytime it talks about replacement, you know this is going to be and. okay, because I want to get 2 different marbles. I'm drawing twice. So first I want to get a red marble, then I want to get a yellow marble. So I'm going to start with my first probability like we've been seeing. Then I'm going to multiply. Now, because I'm putting that marble back in there, I'm starting from scratch every single time. This one's independent, so I just need to multiply my 2 different probabilities. Nothing changes. So to find a yellow marble, my yellow I have 5, and then I still have my 21 marbles in the bag because I put it back in there. So then we get 20 over, let's see, 21 squared, 441. I don't think we can simplify that, but we'll try just to make sure. And we can't, so that's my fraction. That's my probability. All right, now the next one. Okay, I got without replacement, so this is and. Oops, can't spell. And because I'm not putting the marbles back in there, it's dependent, which means my probability is going to change each time. Okay, so starting with a green, I'm going to draw a green marble out, and then I'm not going to put it back in there. So the probability that I get a green right off the start is going to be 3, because I have 3 green marbles out of the 21 total. Then I'm going to multiply that by the probability of getting a blue, but I already took a green marble out, so there's 1 less green marble in there. So I still have all of my blues, which was 7, but I have 1 less marble. So I only have 20 marbles to choose from. Okay, then I want to get an orange marble. I have 2 orange marbles, but I've taken out a green and a blue marble. So that means I'm left with 19 marbles, right? And I still have all of my orange ones, which is 2. And we just multiply all of them together. So 3 times 7 is 21, times 2 is 42. I'm going to use the calculator to get this big number. I get 7980, and then I'm going to use the calculator to simplify. And we get 1 over 190. So my probability of getting these 3 marbles in a row without putting them back in there is a 1 in a 190 chance. All right, then this one I want to get a blue or green. Or means I'm going to add, right? Or sorry, blue or green or yellow. Okay, so this is 1 time. There's no way if I draw 1 marble that I can get a blue and a green and a yellow. So that means I'm just going to add my probabilities. Okay, so the probability I get a blue is 7 out of 21. The probability that I get a green is 3 out of 21. And the probability I get a yellow is 5 out of 21. Okay, 7 plus 3 is 10, plus 5 is 15. Divide them by 3, and we get 5 over 7. Okay, then the last one is a purple marble. Well, I don't have any purple marbles in the bag. So that means my probability is 0. Okay, and I'm going to add one here real quick. I'm going to add the probability of getting a marble. Okay, well, because I have only marbles in the bag, so if I reach in and grab something, I'm going to get a marble. So that means that my percentage or my chances of getting it is 100%. I'm going to get a marble every single time. So we write that with a 1. So your probabilities are going to be from 0% to 100% or from 0 to 1. And 0 means you can't get it, it's not possible. And 1 means you're going to get it every time. Okay. So the next one, we're going to use all of these with a die. We're rolling a die. So for the first one, I want to roll a 4. So to start with, I'm going to list out my options. So I'm either going to get a 1, a 2, a 3, 4, 5, or 6. And this is my outcomes. Usually we put it in curly brackets. We just list them all out. So these are all my possible outcomes. So I have 6 total. Okay, the first one I want to roll a 4. Well, 4 is one of those 6 options. So my probability of rolling a 4 is going to be 1/6 every single time. The probability that I roll an even number, well, my even numbers are 2, 4, and 6. So 2, 4, 6. I have 3 even numbers out of my 6 total. So that's a 1/2. All right, then I want to roll an even number or a number greater than 4. So here's my or. Okay, so I'm going to add. So my probability of getting an even number we just did, I'm going to leave it as 3 over 6 so that I keep that common denominator. Okay, so I have that one plus a number greater than 4. So I have 2 numbers that are bigger than 4, not or equal to. So my options are 5 and 6, so that's 2 out of 6. Okay, but this time I can get an even number that's greater than 4. I can get both of them. that number is 6. Okay, so I counted that 6 in both of these probabilities. I said that the 6 was an even number and 6 is a number greater than 4. So that means I counted the 6 twice, but I don't have any better chance of getting a 6 than any of the rest of the numbers. So I'm giving that 6 too much probability. So because I can get both of these at the same time, I have to subtract the probability of both. So the one that's in both is a 6, so that's 1 out of 6. So these ones are going to be non-mutually exclusive. So anytime it's non-mutually exclusive, we still start out the same way. I add my probabilities, but then I have to subtract the overlap. Okay, so 3 plus 2 is 5, minus 1 is 4, and I can simplify that to 2/3. All right, rolling a 2 and then a 5. So this is and, right? I'm going to multiply. Now, when I roll a die, I'm not going to be able to roll a 2 and then take the 2 out because it's changing the die, right? I'm still going to have a 6-sided die. So if I'm rolling a die, just like flipping a coin, it's always independent. Okay, it's never going to be dependent. The second one, like every time I roll a die, I'm going to pick it up and I'm going to start from scratch again. So it's always going to be independent. It's not going to change the next probability. Okay, so I'm going to multiply. So I'm going to roll a 2. So my first probability is going to be 1 out of 6. And then I want to roll a 5. So that's another 1 out of 6. So I multiply and we get 1 out of 36. So the chances that I roll a 2 and then a 5 is 1 out of 36. All right, then I want to roll a 3 times. Okay, so it's worded a little differently, but that means that I want to get a 3, and then a 3, and then a 3. So this is a bunch of ands, so I'm going to multiply. Okay, this, remember, if it's or, that means it's one event. I want to roll a die one time and get a number or a number or a number. And means I'm doing an event multiple times. I have more than 2 or 2 or more. Okay, so my probability of getting a 3 the first time is 1 out of 6. Then I pick it up and I start again, so it's 1 out of 6. Then I pick it up and I start again, so it's 1 out of 6. So then I have 6 times 6 times 6, which is 1 over 2/16. So very, very slim chances, right? Okay, then I want to roll a 2 or a 5. So that's going to be or. So I'm adding. So the probability I get a 2 is 1 out of 6. Probability I get a 5 is 1 out of 6. So that's a 2 out of 6, which is 1/3. Okay, I can't get 2 and 5 at the exact same time, so there's nothing to subtract. I'm just going to add. Right, and then for the last one, I got or again. I want an odd number or a number less than 5. So my odd numbers are 1, 3, and 5. My numbers less than 5 are 1, 2, 3, and 4. So the probability I get an odd number is 3 out of 6. Added to the probability I get a number less than 5, that's 4 out of 6. Now, if I went ahead and added, that would give me 7 out of 6. That's bigger than 1. That's not possible. I can't get more than 100% when I'm finding probability. This is one of the ones where I can get both at the same time. If you notice, there's a 1 and a 3 in both of those options, which means there's 2 numbers that overlap. So I have to subtract those 2 numbers, or the probability of getting those 2 numbers out. So 3 plus 4 is 7, minus 2 is 5. So my probability of getting an odd number or a number less than 5 is 5 out of 6. Okay, so probability is what you want over the total, right? And then if it's an and, if you have multiple events that you want to get, then you multiply. And then if it's or, if I want one event and I want different options that time, I'm going to add.